Welcome to the shop. In this video, I'm going to be using the 3-axis CNC wood router to make a wood base for one of my glass, wood, and metal sculptures. So let's get going. I start the process with a solid model created in Solidworks, then import it into my toolpath program, which is BobCAM, then create the toolpath and look at it on the simulation to make sure that everything is working correctly. Simulation is a great tool because if you don't have simulation, it's possible for the CNC to do very unexpected things if you make a little mistake in selecting your toolpath or your 0 point or your tool length or anything else. So the simulation is a really great step that kind of gives me extra confidence that everything is going to work correctly. One of the unfortunate things about having a limited amount of space is that I have to share this room with the CNC wood router and the glassworking bench. This is kind of unfortunate because whenever I use the router, it gets dust all over everything and I have to clean the room and clean all my glass. And boy, I wish I had more space. The 3-axis, or actually 4-axis wood router, the 4th axis I use for making Inquala handles, and then over here I have a work holding scheme that I've come up with using wedges and dowels and holes. So I'm going to be putting my blank that I've glued up ahead of time. I've glued the hardwood, the finished hardwood, on top of a kind of a spacer piece that will fit into the clamping, and then cut it. This is a high-speed spindle, 3-phase, 25,000 RPM, running on a VFD, and I'm using Mach 3 software to control this, and works pretty well, so let's get going. Okay, the first step in the process is going to be to home the axes. I have mounted on the router frame some proximity sensors that are surprisingly accurate. I was really pleasantly surprised to find out how accurately the machine homes itself. So now the machine knows where its head is, and previously, when I made the table with all the holes in it, I told the machine where the 0 was, set up an indicator, and precisely measured this inside corner. So now I know that XY0 is at this point, and I'm going to use this tool, this measurement tool, to set the top apart to be 0 before I start cutting. I've got a clamping mechanism here where I've got these wood blocks with pegs in them. Got my part, which is the hardwood that I want to use for the finished object, and that's glued onto just a piece of scrap wood. Put that up against the 0, and then I cut up a bunch of shims, a bunch of regular wooden shims, and I'm going to stack them up to kind of wedge my part in place. This is a very, very simple solution that has worked really well for me in the past. I've made quite a lot of successful parts using this method. Just need to find the combination and just get them all in place. Okay, that is solidly in place. So now, put on the safety glasses. Always, always, always wear safety glasses when working. And unlike the mill, this automatic tool changer, this is strictly a manual operation. So I'm going to put in my half-inch diameter carbide tip straight bit, and to move the bit over the zero finder, and this will reference the tip of the tool to my zero. Now, even though I've run this program before and I'm reasonably confident that it's going to work correctly, when I start the automatic operation, I definitely want to have my finger on the emergency stop button just in case. The toolpath was created in a CAM software called BobCAM. Probably almost impossible to hear me talk with the router going, so I think maybe I'll just do a voiceover after the work is finished. This is the roughing pass. It's removing the bulk of material and leaving a kind of a staircase on the outside. The next pass is going to be done with a round nose router bit, and it will produce a very, very nice finish. The finished pass is actually amazingly nice. going to change tools. I'm going to put in a round nose, also carbide tip router bit. And of course I need to reset the 0 once again because the tool is going to be a different length. And the finish pass will be done in a spiral pattern, and it produces a surprisingly good surface finish. And then the e-stop whenever the machine starts working. Running at 120 inches per minute with a step over of about 20 thousandths, if I remember correctly. Then a spiral pattern, cutter rotating at 25,000 RPM, and it produces a superb surface